friends, today we will discuss about sources and classification of air pollutants. Basically, as you know, we are discussing about air pollution and control in totality. So, we need to know what is the air pollution, what are its main sources, and then we need to know different kind of air pollutants, because to control them we have to have different policies, different technologies for different pollutants. So, unless we know what kind of sources are there and what kind of pollutants are released, then how can we control them. So, basic knowledge or fundamental knowledge about sources and classification of air pollutants is very important. Well, so when we talk about the sources of air pollution, basically you can divide it into like natural sources or anthropogenic sources. Anthropogenic means man-made sources. Then you can also divide them like indoor and outdoor sources. Okay. So, that way major sources. Then within natural sources we can say different kind of sources. We will see what kind of sources are there which can be categorized as natural sources, and what are those sources which we categorize as anthropogenic sources, right. Then within indoor sources also different kind of micro environment related sources can be there. When we talk about types of air pollutants, then there are many ways, several ways to classify the air pollutants basically, okay, depending upon their size, depending upon their shape or physical and chemical characteristics. We can say that physical aerosols or biogenic aerosols, those kind of things. Similarly, the major components regarding types of air pollutants can be like primary air pollutants, secondary air pollutants, or criteria and non criteria air pollutants. Within non criteria like hazardous or toxic pollutants. Then there are greenhouse gases. Strictly speaking, some greenhouse gases like CO2 is basically not pollutant. This is part of our inhalation and exhalation process. Okay. CO2 is part of our system, it is not toxic pollutant, but other pollutants are there which are also greenhouse gases like ozone etcetera. They are air pollutants as well as greenhouse gases. So, in that way to control the greenhouse gases, to avoid climate change, to avoid other effects on global warming etcetera, we need to discuss them as part of the air pollutants. Also some people talk about like noise pollution, that is also the part of air pollution according to them. So, there are different authors, different schools of thoughts, and then even people talk about like light, in the cities so much light is there in the night, okay, that they can disturb the path of birds, migratory birds etcetera. That is also known as space pollution or air pollution. Even some people talk about like banners, advertisements, those spaces are occupied. So, they call it like air pollution of different kind, but strictly speaking the health impact related air pollutants are those pollutants which affect our health, which affect the ecological systems and other effects they have. Then we will discuss about conclusions after all. So, in this picture you can see in totality what are different sources of air pollution. You can see like natural are volcanoes, okay. Then wildfires, natural fires may occur in the forest, okay. So, they can emit lot of carbon dioxide or particulate matter or other pollutants, right. So, forest can be also the source of air pollutants, as I said earlier, like pollens and VOCs, hydrocarbons, whatever smell is coming from a plant or flower, this is basically VOC, volatile organic compound, right. So, those kind of emissions may also be there naturally. Whenever you cut the grass in the lawn, then also you have certain smell, all those are VOCs basically. So, natural emissions of VOCs can be there. Then when we talk about like these man-made sources or anthropogenic sources, so they can be classified like stationary sources or area sources, mobile sources or line sources. So, point sources or stationary sources are basically emissions from certain stacks or chimneys, okay, a point source you can say, right. Also like definition sometimes depends upon the context also, like city is an area source, but if you look at the continental scale, city can be a point. In that context that can be a kind of point source, but in daily life when we talk about urban air quality management etc., then point sources are only those sources like which are coming, the pollution plumes are coming out of a stack or a small heap is being burnt, right. So, those are the point sources. Area sources can be like number of point sources are there, like each household is emitting when we are cooking. So, in the whole colony or city emissions are coming from kitchen, or in some industries, industrial area, so many pollution is coming from different industries. So, that kind in total can be termed as area source. Okay. Then mobile source or line source is basically like on the road vehicle is traveling. So, that can be line source or mobile source. Line source can also be because of like there are number of stacks, like some industries are in parallel of a river bank, and those in the line. So, that is also the line source, or agricultural waste is being burnt in a line in a field. So, that is also a line source in that way, right. So, that way you can see like natural sources, man made sources, and also we can categorize like stationary sources, mobile sources and area sources. Well, so we have talked about in that picture. So, like natural sources may be sea salt or dust storms, sandstorms, and then smoke from wildfire. We discussed volcanic eruptions, volcanic activities are also natural occurring sources of air pollution. Anthropogenic sources, stationary sources like power plants. So, again stacks or chimneys, oil refineries or industries and factories, brick kilns etc. Wherever stack is there, chimney is there and a plume is coming out of it, we call it stationary source or point source. Mobile source, on road vehicles or marine vessels, ships etc., which are moving. So, emission is going on coming out of a chimney of that or stack of that particular vehicle, like exhaust pipe, or in the ship some exhaust pipe is there, and then aircrafts also mobile sources you can call. Area sources like lot of agricultural field emissions are there, or wood burning in a large area. Then waste burning also, like wherever this landfill sites are there, several hundreds of yards or meters occupied by waste, and if it is burned then that can be area source. And then the cooking or slums, wherever emission sources are in a large size area, then we call it as area source. So, basically why do we worry about line source or point source, area source? Because when we try to model, so according to the area source, point source or line source, modeling techniques are different. So, that we will discuss later on. Now, we go for natural sources one by one. So, like volcanic eruptions. In volcanic eruptions, lot of emissions come of different nature, like huge quantity of sulfur dioxide and ash content, particulate matter, those kind of thing, like CO2, even moisture, hydrogen fluoride and hydrogen chloride, all those things they come out of this particular activity. Then SO2 is being converted into H2SO4. So, it can also get converted into acid rain, right. So, that falls as a precipitation or dry deposition that can be there, right. So, this is the way of emitting this volcanic eruption, emitting lot of gases and particulate matter. Well, the gravity of volcanic eruptions can be visualized with this example, like the concentration of sulfur dioxide in tons per day, this which was released from Mount St. Helen eruption from 1980 to 2005 was huge. It was around up to 3750 tons per day of sulfur dioxide it was released during that span of period. So, it was huge quantity you can say. Particulate matter in the smoke and the levels in the ambient air because of that eruption, over the 4 days of eruption it was around 1600 microgram per cubic meter. It is a very high concentration in ambient air, and that was around 5 times of usual normal levels which were observed daily in that area. And the prevailing winds moved around 520 million tons of that ash or particulate matter eastward across the United States. So, the whole region was affected by this volcanic eruption emitting lot of particulate matter. Well, if we talk about in today's context or in current context, so as on 19th August 2021, around 50 volcanoes were counted as in active eruption status around the world, these 50 volcanoes. So, you can imagine that they are emitting huge quantity of gases and particulate matters, etc. Well, then there are natural sources of air pollution in terms of forest fire, right. So, uncontrolled forest fire emits lot of carbon monoxide and carbon dioxide and hydrocarbons also, and ash content, that is particulate matter, and oxides of nitrogen. Okay. Like around 37,000 fires were detected in the year 2018 using this MODIS, moderate resolution imaging spectroradiometer sensor data through the space. Okay. So, and if we count like how much part of the forest is affected by these fires, so around 54% of forest area is exposed exposed to occasional fires, and around 7.5% to moderately frequent fires, and around 2.4% to high incidence level of and 35.7% around means not yet exposed, that is unexposed, you can say in that way, means that was the kind of study based data. When we talk about like Australian bush fire, it is the area and intensity and extent was very vast. The extreme bush fires that blazed across southern eastern part of Australia in late 29 and early 2020, it released around 715 million tons of carbon dioxide into the atmosphere. Okay. And the unprecedented fires burnt across as much as 74,000 square kilometer, okay, of mostly that particular variety of plants. And then this around southeast Australia was affected, and it was the area larger than, if you want to visualize, larger than Sri Lanka, that kind of visualization you can see. Well, when we talk about like other natural sources, for example, sandstorms or dust storms, so they also entrance large amount of particulate matter into the atmosphere, and because of that particulate matter concentration increases several fold, and also it reduces the visibility severely, and because of that sometimes accidents happen on the road. Well, you can see here this dust storm at New South Wales as an example over parts of Victoria to arrive in Melbourne, Australia on January 2020. Okay. So, the air atmosphere became like orange because of this scattering of the light, and the visibility dropped significantly, and it was almost impossible to drive in that situation. So, those are the effects of sandstorm related air pollution episodes. When we talk about further in case of natural sources of air pollution, so the oceans are also very vast emitting sources of air pollutants, and they emit aerosols basically, okay, in the form of salt particles, because wind and that friction is there, then lot of salt becomes part of these aerosols, and then corrosive properties are there because of these aerosols have lot of chlorides, etc., and the coastal locations buildings get affected severely because of that. Well, these marine aerosols are defined broadly as various types of particles which are found over the oceans. For example, like sea salt or sulphate aerosols or nitrate aerosols, mineral dust. So, according to their these physical chemical properties, we can classify them in different types of aerosols. Then there are two distinct types of aerosols which are produced by bursting bubbles. You can see here like bubble goes up and it bursts. So, this film drop and formed from the shattering of the thin upper surface of the bubble, and they are ejected with a wide angular distribution. So, that is one way of creation of aerosols in the air. Another one is like jet drops, okay. So, which produces large aerosols whose sizes are roughly 10% of what is precursors of bubbles diameter. So, that way size related difference is there because of different way of their production. When we talk about like their effect, so lot of corrosion related things happen because of these marine aerosols. As you can see, like this atmospheric corrosion in marine environment and bimetallic corrosion happens, you can see in the figure also. So, marine environments caused higher corrosion in zinc part or these sleeves related parts and galvanized forged steel pin you can see here. So, that corrosion is because of this marine environment emitting aerosols. Okay. Then dust samples accumulated on the pin and the glass part were around 7000 ppm chloride or 41,000 ppm sulphate. So, that kind of high concentration can easily corrode whatever metal it is there, unless it is non corrosive metal is there. Well, similarly in another study this was seen that the influence of marine aerosol decreases with the distance from the seashore naturally because their concentration decreases, but the structures located at certain altitudes in a desertic region can be still greatly affected as seen in this particular picture. Okay. And the these deposit samples on the most affected side of the tower had around 18,000 ppm chloride content. So, that is again very high concentration. Okay. Similarly, this is another example of atmospheric corrosion, corrosion of zinc, detachment of galvanized layer, corrosion of steel, etc. They are part of this particular chemical attack because of marine aerosols. Then in the the part of natural sources can be like pollen, okay, pollen grains from flowers, from plants which can cause several respiratory distress and allergic reactions to many people and animals also. Well, so pollen allergy data if you want to see to have a kind of context, then around 150 million European citizens suffer from chronic allergies during year 2016 as per one data. And by 2025 it is estimated that more than 50% of Europeans will suffer from allergy with no age, social or geographical distinction. So, those are negative effects of these natural sources or naturally emitting pollens. Basically again you can call them kind of particles, but they travel and they can affect our respiratory system. If we see in Indian context like Bangalore, sometimes people write it as a city of allergens or pollens. So, in a study from 2017 to 29, this study was conducted on sensitization among patients with having those patients having allergic rhinitis kind of or bronchial asthma kind of symptoms. So, in clinics they were observed and some data were collected. So, around 400 patients were included in this particular study, and it was performed with 21 these aero allergens extracted from different kind of pollens, and 7 species of fungi and 9 species of pollen and 3 species of house dust mite were considered in this particular study. And you can see the result of this particular study, like percentage of people allergic to different types of pollens you can see in this particular chart, right. Similarly, if you see the percentage of people sensitive to allergies, so like house dust mites is the maximum having maximum role in giving allergy to people. Now, if we talk about from natural sources, if we shift our attention to anthropogenic sources. So, if you talk about like point sources, then industrial stack emissions are basically the point sources as it is shown in this particular figure also, and they can be like from manufacturing of different products. So, you need energy and some sort of fuel is burnt there, and that emission will go out of the exhaust chimney. And if it is not controlled by some equipments, those pollution controlling equipments, then lot of pollution is emitted in the air, and the nature of the pollutant will depend of course on the nature of fuel which is being burnt, right. The major pollutants which are released from stacks, chimneys like these point sources of the industrial units maybe like particulate matter or sulfur dioxide, carbon monoxide, oxides of nitrogen, depending upon which kind of fuel we are using. So, you can see here like this portion of US air pollution that comes from power plants, you can see around 62% of arsenic, 77% acid gases, 60% sulfur dioxide, those kind of data are there from power plant emissions. In India, around 70% of power generation is obtained via coal based thermal power plants, and coal is, people say that this is the dirty source of energy, because it emits lot of particulate matter and lot of sulfur dioxide etc., depending upon the coal quality. But nowadays, this coal is treated well before taking to power plants. So, then pollution levels are a little lesser, and then controlling equipments, air pollutant controlling equipments are also there, like electrostatic precipitators etc. So, pollution level becomes low in that sense, but still huge quantity of coal is burned, then lot of pollution comes out. Large amount of sulfur dioxide, NOx, okay, CO2, CFCs, those kind of things may come out of those power plants. Well, when we talk about line source or mobile source, so automobiles are the major source of air pollutants in that sense, and NOx emissions or carbon monoxide emissions largely come from these automobiles based on gasoline or diesel etc., in a urban setting. So, if you try to compare pollutants, then you will find that in a particular city these CO emissions, NOx emissions are coming largely from automobiles, and hydrocarbons also, VOCs are also in huge quantity, and there may be some other non exhaust emissions also that may be from petrol pumps or like tires etc., those kind of emissions may also be there from automobiles. When we see like area source, lot of waste is burnt in a large area, then waste burning can be a large source of particulate matter. This is uncontrolled combustion, you can say. So, like lot of CO emission is there, and people throw away plastic etc. So, toxic chemicals also comes out of these waste burning sites. That is very dangerous basically, like polycyclic aromatic hydrocarbons, okay, VOCs, CO, particulate matter, and many other things come into the fuel of these waste burning sites. Then if you talk about indoor air pollution, okay, so in micro environment, several sources may be there of the indoor air pollution, like from even our sofa, okay, kitchen activities, even like these washing machines, okay. And when we are mopping the floor, so we are using certain chemicals, so washrooms etc., several sources may be there for the indoor environment. So, we have to be careful of those sources. Even pets are also source of certain aerosols etc. So, there are several sources in the indoor environment, and if you are not attentive enough, then lot of harmful effects can be there to our health, and we are not aware of it, but they are coming from our own setting, our own dwelling units. Then if we see like this scenario of a major source of air pollutants in Europe, then around like means if you want to visualize the in a city, European city, so 90% of these ammonia emissions and 80% of methane emissions come from agricultural activities in European setting, okay. And the waste or landfills, these coal mining and long distances, these transmissions are sources of methane. Similarly, the 60% of sulfur, that sulfur dioxide or sulfur oxides, they come from energy production and distribution kind of activities, and many natural phenomena including like volcanic eruptions are also contributing different kind of air pollutants, and 40% of emissions of nitrogen oxides come from road transport. So, as I said, NOx emissions in large quantity comes from transportation sector. So, you can see different kind of pollutants in European setting coming from different activities, anthropogenic sources in a way. Well, then when we talk about types of air pollutants, because when we want to control, so if we have kind of emission inventory, so we have different quantities of air pollutants with the name. So, then we have idea that okay, this particular air pollutant is being emitted in a large amount, and this is also contributing to certain negative impact to our life, whether environment or our human health. Then we want to control it. So, we want to reduce it. So, unless we have that data, type of air pollutants, their emissions or their concentrations in the air, controlling a technique or controlling policy would be difficult to devise. So, we need to know the types of air pollutants. So, we classify them into different categories like primary air pollutants, secondary air pollutants, or criteria, non criteria or hazardous. So, primary air pollutants and secondary air pollutants, you can see primary air pollutants basically they are emitted directly by exhaust sources, and secondary pollutants which are when primary pollutants are in the atmosphere, then they interact or react with each other, or they react with constituents of the atmosphere. So, then the transformation happens, and that transformed pollutant is known as the secondary pollutant. When we talk about criteria air pollutants, basically they have certain threshold limit. So, like whatever national ambient air quality standard related pollutants are there, so they are criteria pollutants, because based on certain health impact studies, scientists and engineers have prescribed certain limits. Okay, below that limit it is not much harmful. So, that threshold limit is there. Okay. Well, so those are like ground level ozone or particulate matter or CO, lead, sulfur dioxide, nitrogen dioxide, etc. They are criteria pollutants. Then there may be hazardous air pollutants, and you can see around 187 hazardous air pollutants are listed as toxic pollutants, because they can affect our health in any quantity, even if they are present in very small quantity. So, they do not have threshold limit. They are very toxic, and small quantity can also be dangerous to our health. So, when we talk about primary air pollutants, as I said, it is found by as a byproduct of incomplete combustion processes, as the burning of petrol, coal or wood. Okay. Complete burning is there, then basically it is converted into carbon dioxide and those stable products, moisture or what, those kind of things. But incomplete combustion results into certain pollutants which are unstable. They will react with some other things, and they will result into some harmful impact, right. So, during this process there is not enough oxygen available when this incomplete combustion happens. So, they create carbon monoxide as a byproduct, okay. And carbon monoxide is problematic to our this respiratory system, because it goes into the blood, and it reduces the carrying capacity of the blood for oxygen, and with the lack of oxygen we faint, and even death can occur if lot of carbon monoxide is absorbed in our body. And the biggest source of carbon monoxide are basically the vehicles, transport sector, okay, in any city you can see. But good part is that like Government of India is propagating now the policy of decarbonization of transport sector. So, that way if we shift towards battery operated electric vehicles in a large number, then this kind of emissions can be ruled out from the transport sector, but this is the future scenario. Well, similarly sulfur dioxide is also the primary air pollutant, okay. And the most part of the sulfur dioxide comes basically from these coal burning power plants, okay, and other fuels like oil, and they may contain other pollutants also. Well, this is produced in natural sources also, but like volcanoes and hot springs, but anthropogenic sources are also they are quite predominant in terms of thermal power plants. Similarly, NOx, that is the oxides of nitrogen, is there, and which is emitted by fossil fuel burning, and that can come from different activities including transportation sector or power plants, or other activities you can see. And these sulfur dioxide and NOx emissions, they get converted into acid rain kind of thing. Then there is ammonia. This ammonia is like soluble colorless gas, and it has very strong pungent smell, and it is primarily released from animal waste, okay. like fertilizers etc., when used in agriculture, and vehicle exhaust can also produce certain amount. The biggest source of ammonia release is from agriculture practices basically, okay, and from crops, from animals, and that becomes part of atmosphere. Well, when we see in this particulate matter which is this is primary air pollutants. So, that can be of different size and shape also, ultra fine, fine, coarse. So, according to the size like coarser PM10 etc., okay, and then 2.5 PM 2.5 particulate matter which are equal to or less than 2.5 micrometer, they are fine particles basically, and less than that like PM 1.1 they are ultra fine particles, and now people talk about nanoparticles also, okay, those kind of research is going on. So, aerodynamic properties of particulate matter, they decide which size is very dangerous and which is not much dangerous depending upon our respiratory system. So, you can see here like particles go inside, and depending upon their size some particles will come out, some particles will get deposited in the lungs, and very small ultra fine particles or nanoparticles, they can even go to the blood stream. Well, this is the aerodynamic diameter related equation you can see, which decides particles velocity and its impact on human body or respiratory system. When we talk about these diameters, so different kind of values are given: solid sphere, hollow sphere, irregular shape. So, they basically influence the aerodynamic diameter and impact on the our respiratory system. When we talk about like the size and their sources like dust, then dust is basically 1 to 200 micrometer size. So, it is quite coarser particulate matter, and it will get deposited by gravity very quickly. Okay. So, natural disintegration of rocks or mechanical processes are there, the sources, and in sandstorm lot of that dust is, or like resuspension of dust because of vehicles also occurs. So, these are the particles basically of that large size. Then if we talk about smoke, so that has like fine particles around 0.01 to 1 micrometer, and this is the basic source is combustion and chemical processes, and chemical or metallurgical processes they also release some sort of fumes which are of 0.1 to 1 micrometer size. Then if we talk about the mist, which is because of condensation or industrial operations, which is less than 10 micrometer. So, PM10 you can talk about in the mist those. In fog less than 10 micrometer basically in the mist with water as liquid droplets, and aerosols can be less than 1 micrometer, which are airborne suspension. So, as you can see 1 micrometer is 10 to the power minus 6 meter, 1 nanometer 10 to the power minus 9 meter. So, depending upon the source, different size of aerosols or particulate matter come into the air. So, these are the pictures you can see, you can visualize like the dust source, okay, resuspension of dust etc., smoke from vehicles, exhaust vehicular exhaust pipes, industrial fumes, okay, and then chemical fumes can also be there because of some reactions, mist, fog, aerosols, there are different sources you can see here according to the classification of particulate matter. When we talk about the dust particle size and penetration in respiratory tract, so these very small particles, ultra fine particles can go up to the lungs, and even this part of the lungs which are alveoli, okay, where this transaction of exchange of oxygen happens in the lungs and the blood. So, that may be affected by those ultra fine particles. Otherwise coarser particles get trapped into our nose, which is natural filter system you can say, and then 3.3 to 4.7 micro kind of size, this can be part of this our windpipe. So, they can deposit it, they can cause some allergy, and this windpipe gets swollen, and then it becomes uneasy to breathe. So, those kind of things can be there. When we try to see what is the relative size of particles, so it is a good picture which can help you to visualize the particle size according to like human hair. So, human hair around 50 to 180 micrometer. So, according to that you can see fine beach sand can be around 90 micrometer, right, of that size. Similarly, you can see other like grains of pollen of 15 micrometer. So, that way you can see there are particles which we can't see from naked eyes, so small, and they are hanging around, floating, and suspension in the air, and they becomes part of our respiratory process and affect our health. Well, when we talk about secondary air pollutants after the primary air pollutants, then we talk about the major secondary pollutant, which is ozone. And ozone, it is very dangerous. It is having multiple negative impacts, like it is greenhouse gas which contributes to global warming. In tropospheric ozone I am talking about, where it is really problematic for us, but in stratosphere it is good because it prevents ultraviolet rays to reach to the planet earth, as you know. So, there it is good, but in troposphere it is very bad, and then ozone is also very toxic to our body because it is highly oxidizing agent. So, in that way it is highly reactive gas and composed of 3 oxygen atoms, as you know, and it is formed in the photochemical reaction in the presence of sunlight when precursors are there, like volcanic these volatile organic compounds, VOCs, and nitrogen oxides, okay, those plus carbon monoxide also, those are the hydrocarbons, etc., they are the precursors of ozone. Then if we talk about good and bad ozone, so that is nothing but these stratosphere ozone and troposphere ozone. Troposphere ozone we call that it is not good because it is harmful in several ways, it damages our property, rubber tires, etc. Okay. Then if we talk about like photochemical smoke, so that is again because of several reactions in the atmosphere. It is composed of particulate matter, oxides of nitrogen, ozone, several kinds of aldehydes, then peroxyacetyl nitrate PAN, and then there are unreacted hydrocarbons also. So, they in total create some sort of smoke. Okay. And this smoke is often in brownish haze, and it reduces the visibility also, and it can cause eye irritation and those kind of things, and nitrogen dioxide is also part of that. Well, similarly if we talk about criteria air pollutants, so those pollutants which are having certain threshold limits, okay, and certain guidelines that concentration should not exceed from that, below that it is not very problematic. So, these are ground level ozone or particulate matter, carbon monoxide, lead, sulfur dioxide, nitrogen dioxide, etc. Okay. So, they are defined in National Ambient Air Quality. I would request you please visit the website of Central Pollution Control Board and then see the National Ambient Air Quality Standards. Similarly, you can find for USA at the EPA site. WHO has also provided certain guidelines for certain criteria air pollutants, but for us like in Indian context we need to follow these NAQS, National Ambient Air Quality Standards of Ministry of Environment and Forest through CPCB, Central Pollution Control Board. When we talk about hazardous air pollutants, so these are known criteria air pollutants, and small concentration also very dangerous, like benzene, dioxin, toluene, heavy metals, all these are very toxic, and small concentration can also disrupt our system. Some are carcinogenic which can trigger the cancer into the body. So, we should be aware about the exposure to these hazardous pollutants, and we should try that they are not emitted in our surrounding and they are captured properly, and they are not part of the ambient air or indoor environment also. So, these are around 189 pollutants are listed by EPA. In 1990 modified list of 187 hazardous air pollutants are there. So, CS number is unique numerical identifier which is assigned by Chemical Abstract Service. So, that way you can find their names and their number, and when we click at that number we can get the detailed information about that particular pollutant. Then we talk about greenhouse gases. So, as I said, like CO2 is not a problematic, it is not a strictly air pollutant, but when we talk about other like methane, nitrous oxide, or these ozone etc., they are problematic, they are also air pollutants. So, when we are controlling air pollutants, so it is easy to list them as a part of air pollutants, so that we can control their emissions also, right. So, if you see greenhouse gas emissions around 68% okay, in India, the greenhouse gas emissions are coming from energy sources. So, energy sources basically like thermal power plants etc. In the US, if you see like industry 23%, electricity generation 25%, transportation 29%, and commercial residential they release around 13% of greenhouse gases as per 2019 data. And then if we see the trends, okay, greenhouse gas emissions trends from 2005 to 2013 in Indian context. So, you can see it is not very sharp rise like China, but it is still increasing trend, but it is up to 2013 data. Now, government is giving a lot of incentives for going for solar energy, renewable sources of energy etc. So, that way, and this decarbonization policy for transport sector. So, in future I hope air pollution emissions as well as greenhouse gas emissions will be reduced in India significantly. Well, so in conclusion we can say that the sources of air pollutions can be classified on the basis of their origin or types of emissions, natural, man made and indoor, outdoor etc. And those air pollutants can be categorized in different way like criteria or non criteria pollutants, hazardous pollutants, right. And for air quality management we should know basically what are different kind of sources and what is the difference between different types of pollutants, whether it is primary, secondary, so that we become more aware which kind of pollutants is responsible for deteriorating our air quality. So, particular that pollutant we should first target, so that we can have better air quality. So, this is all for today. Thank you for your kind attention, and you can go through these references for additional information, and see you again in the next lecture. Thank you.